Chapter 8, Hypothesis Testing for Population Proportions. And remember that for Chapter 8, we're covering 8.1, 8.2, 8.3, 8.4. So I'm going to try to do 8.1 and 8.2 separate, even though the homework are combined. And then I'll do the problems for Chapter 8.1 first, and then in the second video, I'll do the problems for Chapter 8.2. One main topic for Chapter 8, how to conduct hypothesis tests involving 1 and 2 population proportions. So the essential 8.1 is where we are at right now. The essential ingredient of hypothesis testing, and that is to write a null and alternative hypothesis for a test involving a population proportion, and then how to compute and to interpret a statistic and p-value. Okay, those are our two objectives. So first of all, let's define a hypothesis test. So a hypothesis test is a procedure that enables us to choose between two claims when we have a variability in our measurements. Now, if there's no variability in the measurements, then we don't need a hypothesis test, okay? But when there's a variability, we need a hypothesis test to determine, to help us choose between the two claims, right? There are 4 general steps involved in using the hypothesis test. One is to state the hypothesis or the claim that will be weighed against a neutral skeptical claim. Second step, prepare. Determine how you use data to make your decision, and make sure you have enough data to minimize the probability of making mistakes. In continuing, then we collect the data and compare them to your expectation, and then finally interpret or state your conclusion. Do you believe the claim, or do you find that the claim doesn't have enough evidence to back it up? Okay, so our first step, 4 steps: hypothesize, prepare, compute and compare, and interpret. These 4 steps are also going to be used in Chapter 8.2 and going forward, so pay attention to them. All right, now we're going to talk about a pair of hypotheses. Okay, when we're talking about more than one hypothesis, excuse me, the plural has an E in it, okay? So the null hypothesis, the neutral status quo skeptical statement about a population parameter, always contains, is equal to. Okay, that's described as the null hypothesis. We're going to see how this works in a little bit, okay? And then the alternative hypothesis is the research hypothesis, the statement about the population we intend to demonstrate is true. Always contains less than, equal than, or not equal to. So null hypothesis would always have the equal sign. It's the skeptical statement about a population parameter, and the research hypothesis is the alternative hypothesis, and we'll recognize it because it would always have less than, greater than, or not equal to. Okay, very important. Hypotheses are always about population parameters. They are never about sample statistics. Okay? Always about population And we know that when we talk about population, we talk about parameters. They're never about the sample statistic. In other words, the hypothesis is going to be about the population in general. All right, things about the null hypothesis. The null hypothesis always gets the benefit of the doubt throughout the hypothesis testing procedure. Important, we only reject the null hypothesis if the observed outcome is extremely unusual, if the null hypothesis were true. It is analogous to assume that a defendant in a jury trial is innocent unless proven guilty beyond a reasonable doubt. Okay, so the null hypothesis in this case is that the defendant is innocent, right? And if the observed outcome is that by reasonable doubt that the defendant is guilty, then we would reject the null hypothesis. Okay, so that jury trial is innocent, that is the null hypothesis, that is HO, that the defendant is innocent. And then we have to show, okay, based on observations and evidence, that the defendant is not innocent. Okay, so there's the analogy that we're looking for to explain this. Now let's talk a little bit about global warming here. A 2014 Pew poll found that 61% of Americans believed in global warming. A researcher believes this data has declined. State the null hypothesis and the null hypothesis and the alternative hypothesis in words and in symbols. So pay attention here. This 61% of Americans. Now, the null hypothesis, H subscript 0, says that P is equal to 0.61, which is 61% as a decimal. The same proportion of Americans believe in global warming as in the past. Okay? 61% is the same proportion of Americans who believe in global warming as in the past, as currently. Now, that's saying, that's our null hypothesis, that 61% believe in global warming. This researcher believes that the rate has declined. So the researcher, the alternative hypothesis, H subscript A, believes that the probability is less than 61%. This is the proportion of Americans who believed global warming has decreased. Unless we can find evidence to reject the null hypothesis, then we have to believe what the null hypothesis is saying. Okay, this is just an alternative hypothesis. All right, let's talk a little bit about one-sided versus two-sided hypothesis. The sign in the alternative hypothesis determine whether a hypothesis is one-sided or two-sided. So P is equal to P0 is two-sided, and in the alternative P is not equal to 0, P0 is two-sided. If we see equal or not equal, we know it's two-sided. One-sided to the left, P is equal to P0. Notice P is equal to P0 for all of them. Okay, that's the null hypothesis. If we see less than, it's one-sided to the left. And if we see greater than, it's one-sided to the right, where the p-value is greater than the null hypothesis value. Here's an example. During the previous fiscal year, 30% of retailer sales were due to online sales. In an effort to increase this percentage, the retailer has purchased ads on social media sites. The retailer gathers data on types of sales on a sample of 20 days during the current fiscal year. Has there been a change in online sales? Write the null hypothesis and the alternative hypothesis for the retailer. Is this one-sided or two-sided hypothesis? What other hypothesis could the retailer has put? So pay attention to the 30% here. Okay, the null hypothesis is that P is equal to 30%. Okay. Now, in an effort to increase this percentage, the retailer has purchased ads. The retailer gathers data on the types of sales of the 20 days during the current fiscal year. So the retailer is trying to prove that the sales are not 30%. Okay? That the online sales are not 30%. That's the alternative hypothesis. This is a two-sided hypothesis for this particular case, okay? Now, the second question says, is this one-sided or two-sided? And we know that this is a two-sided hypothesis because he or she is trying to prove that the sales were not 30%. Now, if the retailer had used the words increased or decreased, then we would have a one-sided hypothesis. If he had said, have the sales increased, we would use greater than, and this would be a one-sided test to the right. If he had said, have the sales decreased, then we would have used less than, and this would be a left-sided test. Okay? Hope you can see the difference here. So because he or she didn't use increase or decrease, we have to assume that they're just trying to find out in general, both sides, whether it increased or decreased. That's why we have a two-sided hypothesis. The significance level is the probability of making the mistake of rejecting the null hypothesis when in fact the null hypothesis is true. The probability of making the mistake of rejecting the null hypothesis. What probability would I have of making a mistake when rejecting the null hypothesis? That's called the significance level. The symbol for significance level is the Greek letter alpha. And for most applications, a significant level of 0.05 is used. Sometimes you use 0.01 and sometimes 0.10, but most of the time 0.05. The test statistics compares our observed outcome with the outcome we would get if the null hypothesis is true. When the test statistic is far away from the value we would expect, that if the null hypothesis is true, we reject the null hypothesis and conclude the evidence supports the alternative hypothesis. Again, when a test statistic is far away from the value we would expect, that if the null hypothesis were true, far away meaning that if I had a null hypothesis of 0.3 and the test statistics is 8.5, then I know that something is wrong. We would We reject the null hypothesis in that case and conclude the evidence supports the alternative hypothesis. Now, this is done by technology, and in 8.2 we will look at how this is done by technology. The test statistics has an observed structure. Z is the test statistic, is the observed value minus the null value divided by the standard error. And we remember using the standard error in chapter 7 to find SE, where SE is equal to the square root of P0 into 1 minus P0 over N. And in this case, P hat is the sample proportion from your data, and P0 is the proportion found in your null hypothesis H0. This is generally done using technology, so we're not going to worry about it too much, okay? In 2001, a Gallup poll reported that 12% of Americans were cool skeptics who reported worrying a little or not at all about global warming. In 2014, 25% of those responding to a Gallup poll classified themselves as cool skeptics. Okay, so in 2011 it was 12%, in 2014 it was 25%. Assume that the sample size for the 2014 poll was 500. Okay, can we conclude that the percentage of Americans who identify themselves as cool skeptics has increased since 2001? So this would involve calculating the test statistics and explaining the value in the context. Now, in 2001, the p-value is given as 12%. The null hypothesis p is equal to 12%. And the alternative hypothesis is that p is greater than 12%. Using these two numbers and the 25% in 2014, okay, z is 25 minus 12, or 0.25 minus 0.12 over the standard error. And standard error is computed using the original percentage p is equal to 12%, right? And putting that in a calculator gave 8.95. The observed value of the test statistics is 8.95. This means that while the null hypothesis claims a proportion of 0.12, the observed proportion was much higher, 8.9 standard errors, 8.95 standard errors higher than what the null hypothesis claims. Okay, so can we conclude that the percentage of Americans who identify themselves as cool skeptics has increased? We're going to come back to this once we understand something here, okay? The null hypothesis tells us what we expect when we look at our data. If we see something unexpected, that is, we're surprised, then we should doubt the null hypothesis. If we're really surprised, then we should reject it altogether. The p-value gives us a way to numerically measure our surprise level. It reports the probability that if the null hypothesis is true, our test statistics will have a value as extreme or as more extreme than the value we actually observe. Small p-values, close to 0, mean we're really surprised. Large p-values, close to 1, mean we're not surprised at all. Okay? That makes sense? Small p-values that are close to 0 means we're really surprised. Large p-values close to 1 means we're not surprised at all. If we get a p-value that is less than our significance level, our p-value is considered small. We're really surprised, and we reject the null hypothesis. Here we go. If a p-value greater than or equal to our significance level, our p-value is not considered small, and we're not surprised, and we do not reject the null hypothesis. So, in this example on global warming, we had a test statistic of z is equal to 8.95. And I'm purposely not emphasizing how to compute that z statistics because we're going to use our calculator to do that. Using StatCrunch, we can calculate the probability as the test statistic is extreme at 8.95. The p-value, when we put that into StatCrunch, is equal to 0. This is strong evidence to reject the null hypothesis. Okay? Remember, our p-value is considered small. We're really surprised. And we reject the null hypothesis. So because this is very close, in fact, is approximately equal to 0, we reject the null hypothesis. We conclude that the percentage of Americans who identify themselves as school skeptic has increased since 2001, okay, based on a null hypothesis that P is equal to 12%. Okay, so we're going to come back to that calculating the z statistic in chapter 8.2 later on. Let's go ahead and look at the questions. So chapter 8.1 are questions 1 to 15. And chapter 8.2, which we will discuss in the next video, is 16 through 26. Okay, so I'm only going to discuss the first 15 questions at this point. Again, from our notes, the null hypothesis is always about the population parameter, never about the statistic or the sample statistic. In statistical inference, measurements are made on a sample because it's not possible to do the entire population, and generalizations are made about the entire populations. All right, let's move on. Excuse me. A research hospital tries a new antibiotic scrub before surgery to see whether it can lower the rate of infections of surgical sites. The old rate of infection is 4%. The null hypothesis is that the proportion of infections is equal to 4%. What would be the alternative hypothesis in words and symbols? So we're trying to see if we can lower it. We're trying to find an alternative that says less than. In other words, we're simply saying the proportion of infections is less than 0.04. Has nothing to do with anything else here. Okay? The proportion of infections is less than 0.04. In other words, P is less than 0.04. Notice we haven't calculated anything yet, right? Question 4, a magician claims he can cause a coin to come up with heads more than 50% of the time. Again, more than 50% of the time. Let's emphasize that is highlighted more than and 50% of the time. Already the null hypothesis would be P is equal to 50% or 0.50 as a percentage, not P hat, okay, P, not the sample proportion. And we're trying to say it's more than, so P is greater than 0.50. Okay, never use P hat for this. A new drug is being tested to see whether it can reduce the chance of an asthma attack in people who have had an asthma attack last week. Reduce. The rate of asthma attack in the population is 0.12 or 12%. The null hypothesis P, the population proportion using this drug, notice not the sample, the statistic, the sample, but the population is 12%. What is the correct alternative hypothesis? So we're trying to reduce, so the correct alternative hypothesis is that P would be less than 12%. A coin is flipped 30 times and lands on heads 18 times. You want to test the hypothesis that the coin does not come up 50% heads in the long run. What is the correct null hypothesis? So you want to find out that the p-value is not equal to 50%. Where is it? Right here. That the p-value is equal to 50%. That's your null hypothesis. That is the assumption that it's 50% unless you can show otherwise. Okay? So this would be your null hypothesis. You have to prove that wrong. And in this case, 18 out of 30, so the person did prove that the null hypothesis is incorrect, but we're not going to get into that yet. Okay? All right, here we go. According to a reputable magazine, the dropout rate for all college students is 30%. Okay? Suppose that 98 out of 300 random college students with loans drop out complete parts A and B below. And they gave us the printout here, okay, to view the graphical technology output for the situation. Now, the null hypothesis is P is equal to, okay, let's write it out properly. Null hypothesis H0 is that P is equal to, and the percentage given is 30%. The alternative hypothesis HA P, and in this case we're trying to say it's not equal to 30%. Remember, this is two-sided, so not equal to 30%. So 0.30, we have to put it as a decimal. If it were one-sided, then we would say less than or greater than, depending if it was on the left or on the right. But in this case, it's two-sided. Report the Z statistic from the output given. So right there is the Z statistic. Z is equal to 4 decimal places, 1.0079. Okay, notice they're not asking us for conclusions as yet. We're going to get into that more in chapter 8.2 and perhaps later in the section. Okay. Question 8. Now they gave us a printout of oops, what did I do here? Okay, sorry. Okay. A left-sided, so less than. According to a reputable magazine, 31% cars of all cars sold in a certain country are SUVs. Suppose that a random sample of 300 recently sold cars show 80 are SUVs. Complete parts A and B below. So, if we were to consider 80 out of 300, that would be less than 31%, which is why this is showing a less than characteristic here. So the null hypothesis is that P is not equal to 31%. Sorry, that P is equal to 31%. And we're trying to prove this wrong. So the alternative hypothesis is that P is less than 31%, based on the fact that it's left-sided. The Z statistic from the printout here is 1.6228. Question 9. Suppose a researcher is testing someone to see if he or she can tell soda X from soda Y. So they've got Pepsi and Coca-Cola, and the researcher is checking to see if somebody who's tasting it can tell the difference. And the researcher is using 22 trials, half with soda X and half with soda Y, so 11 of each one. The null hypothesis is that the person is guessing. Okay, very important that the person is guessing. They don't really know. The alternative one-sided hypothesis is that P is greater than 0.05. The person gets 16 out of 22. The p-value comes out as 0.017. Explain the meaning of this p-value. So this p-value is the probability that that person will get 16 or more right if the person is really guessing. Okay? Comes out as 0.017, which is a very small percentage. And it's the probability that the person will get 16 or more right if the person is truly guessing is about 2%. Okay, 2%. Okay, now, if you're asking about the 2%, okay, we round this 0.017 times 100, which is equal to, 1.7, which is approximately equal to 2%. So the probability that a person will get 16 or more right if the person is truly guessing is about 2%. See what happened there? There's only a 2% probability if this person is guessing that they will get 16 or more right, that they will guess Coca-Cola instead of Pepsi 16 or more times correctly. All right, the rest of these are questions from the notes. I can give you a few of them. Which of the following best describes the hypothesis? So remember that the hypothesis are statements about population parameters. In hypothesis testing, the null hypothesis is described as, the null hypothesis always gives the benefit of the doubt. Okay? You're always getting the benefit of the doubt. Look for that. And is assumed to be true throughout the hypothesis testing process. The significance level, anybody? Significance level, let's go back to our notes and see what it says about significance level. Okay. The probability of making the mistake of rejecting the null hypothesis when in fact the null hypothesis is true. So going back to our choice of answers here for this question, okay, question 12, the probability of rejecting the null hypothesis when in fact the null hypothesis is true. Okay, that's your probability of getting it correct. All right, I'm not going to give you this one. Okay, which one of these numbers is most often used? You guys can get that one. What is a true What is true? A hypothesis test. In a hypothesis test, the farther the test statistic is from zero. Yes, I'm waiting. Yes, that's correct. The more the null hypothesis is discredited. And finally, a p-value small p-value generally discredits the null hypothesis. We discussed that in some detail. All right, so until we do chapter 8.2, this is it for 8.1.